Hi everyone, you're welcome back to the second part of our first lesson on MATLAB for engineers. And we want to wrap up this first lesson by discussing variables and data types. Now, a variable is a placeholder for a value which may be of any type. It could be numeric, logical, uh, string, different types of values. And you could consider a variable as a tag or a name tag for whichever value it holds. Now, as we'll see, variables are a key part of any programming language or programming in general. And it's a fundamental concept, and that's why I'm going to treat it very early on. Now, variables are used to store values, and this allows easy reuse anywhere else in the code. Usually, if you intend to perform calculations of any kind, you'd create a variable very early on, and then at a later point in the code, you can call that variable, and the value that the variable held beforehand will be updated and reflected anywhere that variable has been called subsequently in the code. Now, this has it's a very convenient feature. It allows the code to be readable in the first place. You can create variables early on and dedicated section and easily identify these variables using possibly comments, or some of the variables are self-explanatory depending on how the names are set. And then subsequently, when it's called, only the variables need to be called once or anywhere else they are needed in the code. And this is pretty much how we also use variables in standard mathematics in writing solutions for problems and manipulating equations in MATLAB. In mathematics, we tend to represent equations in a variable form. So PV equals nRT is representing all of these terms in equation variables. It's the pressure, volume, temperature, uh, and so on can take different values. And in general, we represent them with these variables that stand for the values of pressure and so on. And when it comes to coding, it improves the readability of programs and algorithms. Like I said, variables can be self-documenting, and it allows the segregation of complex relations for easier computation. Variables also enable algorithm generalization. So, as we stated earlier, if you have PV equals nRT, for instance, the temperature is represented by a variable, which allows you to take it allows to take any value, physical value appropriate for the temperature. It also applies to other variables. You can N here represents moles, P represents pressure, and the equation signifies a general representation of the relationship between these variables. Now, without the variables, if we had to place the values directly there, if we knew a pressure, say atmospheric pressure or 10 times atmospheric pressure, and we placed these values in that form in the equation, we'll see that not much is communicated just by looking at the numbers. These numbers could be anything. It could be a number of people in a class. This is an integer. This is a decimal. It could be anything. So the variables enable us to generalize algorithms and gives us, while giving us enough information about the nature of the relations we are dealing with. So now let's look at how variables are assigned in MATLAB. From this point onwards, we are going to incorporate variables in our code, and we'll see how quickly it improves uh, programming. Now, unlike other programming languages, MATLAB does not require the declaration of variable type prior to assignment. So certain programming languages require that before a variable is declared or a variable is created, its type is assigned. You need to declare the type of a variable before creating it. But for MATLAB, the variable type is assigned, uh, is determined upon assignment. So once the value is specified for that variable, MATLAB immediately assigns or determines the variable type from the value. Now the syntax for declaring a variable is such: the name of the variable equals the value. So the equal to sign here is not the same as the mathematical equal to, or it does not mean equality. It is for variable assignment. So that is the keynote. For equality, we use two of the equal signs uh, sequentially. Now, a common mistake with variable assignment is to flip the order to place the value before the name, and that will return an error in MATLAB. Now, MATLAB also executes code from top to bottom. So the variable assignment is the first instance a variable is created and assigned a value. So once you create a variable, say x equals 5, the x, it becomes the variable name, and 5 is the value specified for that variable. Now, if along the line x is used anywhere else, for numerical computation sake, the value 5 is used for the computation. Now, after assignment, the variable and its properties usually be reflected in the workspace. We identified the workspace earlier, and information about the variable, its values, and the type, variable type, and so on will all be shown in the workspace. And then now the variable can be used anywhere else in the code to reflect the value. And the thing to notice, in order to use a variable, it must have been declared at some point earlier. So if you write PV equals nRT in MATLAB to compute any of these variables, you need to ensure that anything that equation needs for the computation to be done should have been declared earlier on. Other than that, MATLAB would return an error showing that the variable has not been declared at any point in time before its use. Now, if you create a variable for the first time, so for example, you have tc equals 45, this should create a variable tc, and the value it holds is 45. Yeah. Now, if you at any point in time assign a value to tc again, what happens is the next time you call tc at any point in time, it will use the most recent assignment for tc. So for instance, over here we have tc equals 45. Then there is tk, which converts that to Kelvin. This is temperature in degrees Celsius. Let's convert it to Kelvin. And up until this point, tc is still 45. We have not even used tc in this equation. Now over here, tc is called again, and we have tc equals tc plus 1. Now for this computation to be done, MATLAB needs a prior value of tc. It needs this value, and it takes it from the earlier declaration for tc. And then at this point, tc is recalculated because it's been declared again. So the value from this point on, the value of tc used is this, whatever is obtained from this. However, the next line also defines tc to be 0.8. So when it comes to this last line, the value of tc used is just the last one. All of these do not play any role any longer. So the latest assignment is what matters. So tk here is calculated based on this value of tc. Now the number of rules when it comes to selecting variable names as well. In order to avoid errors, there are rules for assigning variable names. One, in general, the name of the variable should be closely related to the value it holds. This is important for several reasons that benefits the user or the program. MATLAB will not complain if you name, say for instance, you were indicating the pressure of a gas, and you called it x equals 10. MATLAB will process that normally, but it becomes difficult tracking your variables later on because um, the name is unrelated to the value it holds in any way. So that's a very general naming. It's usually advised not to write code in that way. Now, a variable must begin with an alphabet, cannot have spacing, but may contain digits, underscore, and letters. But at the beginning, it should always be an alphabet. Now, variable names have limits, so you cannot, the name cannot keep going forever. There is a maximum allowable length, but the minimum is just one character. Now, they are case sensitive, and then there are a few reserved words and inbuilt functions that should not be used. And then we have a few variable commands. So from this point on, we will go into MATLAB and then take some examples to demonstrate these. So first, the simplest of variables, let's say x equals 5. Now, once we do that, we come to the workspace and then we realize over here that a variable x has been created. So this signifies the name of the variable. You have the value, which is what that variable stores. And then we have the class. Now by default, MATLAB assigns the double data type to numbers. So if you create the double is just a floating point, double precision decimal. So floating point is a decimal and a real number, a decimal. And double precision here indicates the number of digits it stores. So the level of precision that is stored for this value. So by default, it's double. You can change it upon assignment or even afterwards. So when we get to data types, we'll talk about this in more detail. So more information about the variable can also be obtained, the size, the bytes, or the number of storage units. All of these can be obtained from the workspace. Now let's try to create more variables. So let's say my name equals so this creates a variable my name, and this is fine. It begins with a character or a text or an alphabet, and then I'm able to allowed to have an underscore in here. I could maybe call this, could create a variable my first name, and this should still pass. So in here I have alphabets, I have a number, I have underscores, and it's still fine. I followed all the rules for naming. Now this first type is a string, and this is a character. Again, we'll talk about this when we hit data types. But let's try to violate some of the rules first, or maybe for our last. First, let's take this. Let's try. So let's call the variable first. So if we just type x anywhere here, the value for x is returned. Now we have already declared that x is 5. So anywhere we call that, we obtain it. Now let's do my name. That also returns the string Martin, which we defined or declared earlier on. Now we are going to call my name, and then we realize that does not return what we would expect, and this is because MATLAB variables are case sensitive. So my name here beginning with caps with a small letter or lowercase alphabet is different from my name here where M is in uppercase. So it says unrecognized function or variable and asks if this is what you intend. So once you hit enter, all right, my name, then we are able to obtain the appropriate variable. Now let's also try to create a variable with starting with a number. So first name. So here we obtain an error, invalid expression, checking for operator and so on. So MATLAB assumes some kind of numerical operation is intended and then complains about the inability to multiply the number and the alphabets, of course. So this is error you encounter if you try to begin a variable name with a number or a numerical value. So I ask if you intend to use this instead. The version where the one is omitted. But if that one was just placed even here, it solves the problem and you're able to create a variable of interest. Now, if we reassign my name, we reassign this, and when you call my name, you obtain the latest assigned value, right? Even though my name has been declared previously, yeah, the latest one is what the variable holds. So if you come here, you realize that my name is currently stores the value Frank rather than any of the other names that was assigned earlier on. So let's also try this version where we swap the position of the name and the value, and then we get the problem again. Assign a value to a variable using this and compare values using this. So the problem here is having the value before the variable name. Now that we have created a variable, let's try to use it subsequently. So let's say y depends on x. So this should work because we have already created a variable x somewhere in our code, and MATLAB knows the value for this x, so it's able to compute y. Now say we wanted to create z, and z was y plus f. Now that returns a problem unrecognized function of variable f, and that makes sense because we've not defined f anywhere in the code up until this point. Y is defined, so the value for y is present. Now let's look at a few functions for dealing with variables in the workspace. Basically, there's clear, clearvars, and then CLC. Now, clearvars is for clearing variables within the workspace. So we could say clearvars. Now, if we specify the particular variable we are dealing with, we could eliminate just that variable. So we could say clearvars y, and that should eliminate y from our list of variables. So when we come to the workspace, we see that y is no longer present. Now, we could also just clearvars, and if we don't specify a variable, all our variables will be deleted. So if we do this, all of them go. Now, if we wanted to specify maybe two variables, what we could have done is clearvars and then y and then x and so on, and it would have deleted them one by one. Now, aside clearvars, we could just use clear. Now, the difference between clearvars and clear is clearvars deletes variables. Clear deletes everything, variables, functions, anything you have in there. Clear takes care of that. Now, then you have CLC. CLC is just for wiping the command window clean, resetting your command window for you. So here we have a bunch of code and errors. And if we wanted a clean slate, we could just use CLC. And that resets the command window gives us a fresh or blank command window. So CLC does not touch your variables. If we type CLC, you would still have your variable names in here. For instance, if I have x equals 5 and I hit CLC, that will just clear my command window, but the variables will still be there. So I can use the variables y equals x plus 6 and it will compute because MATLAB still has that variable stored in there. So the only way for me to deal with it really would be to just clear it in this case. And then if I want to a blank command window, I use CLC. Now let's look at the example from earlier on where we had the temperature. So I'm just going to copy this quickly. And when we look at the last value of TK, where you realize it's 273.80. Now TC, or if we come to the formula for TK, we have TK being TC plus 273. So this is evidence that the value of TC being used is 0.8. And we can see that here. It's 0.8. Regardless of whatever the initial or previous values were, the latest declaration is what is used. Now let's take another example that's clear. Let's take another example. So here we have a rigid gas storage tank which contains air at a temperature of 300 Kelvin and a pressure of 100 kilopascals. Now the gas constant here has been provided, and using the ideal gas equation, calculates the molar density of the gas, or the concentration, the number of moles per unit volume. So if we manipulate this equation, we are looking for N per V. So that should be N over V equals P on RT. So the first thing to do is determine dependent variables, in this case, an independent variable. So we have the independent variables in this case being RT and P. Now R is actually a constant, so that is fine. So P on RT, and those are the three values we need. We need the pressure, the gas constant, and then the temperature to be able to find molar density. So those become the variables we have. So let's go into MATLAB. So the first thing to do will be to specify what that pressure is. So P, I'm using uppercase P, and according to the problem, it's 100 kilopascal. So if that's the unit you are going to use, then we can specify that straightforward. So P equals 100 kilopascals. So that is the value. Now, if I run this as it is, right, MATLAB quickly return the output, right? So if I do not want the output, I can suppress it. So let's do that again. Let's clear the variable. Now P equals 100. If you place a semicolon right after the value, you can have MATLAB suppressing that output. So in this case, value is not returned, and I can go on and use as I deem fit. So I'm just going to clear this again because I want to comment them. Now to comment, you use the percentage sign. Now comments are just, as the name implies, a comment in your code. It's usually useful to let people know exactly what is going on at different junctures within the code. So MATLAB skips comments when it's running the code. Once it sees that lines come after the percent symbol, it ignores it. So I could now say this is the pressure in kilopascals, and that's a very useful feature. I could do same for the temperature. We had, I think, 300 Kelvin. So that's fine for our variable definitions. Now we need to create a variable for our molar density. So let's call it big C. We could call it M because it's actually just molarity, but let's call it big C. And that should be the pressure P on RT. So the gas constant. Now let's not forget the operator precedence rules. If we leave this as it is, we would have P on R being computed and then multiplied by T. That is not what we want. We want P to be divided by the product of R and T. So we need that to be computed first, and we are going to place that in parentheses. So we do not want T multiplying the whole expression. We actually want it dividing by just multiplying out. So this is fine, and we want the answer for this, so we not suppress it. Or we could either way and just call it when we want. But for now, we'll not suppress it. Well, this is so that should give us the answer or the concentration in or the molar density. Right. So now the units for this we could determine. So ideally we should have added that to a comment. That should be moles per cubic meters. Now the other part of the question was asking us to recalculate if the temperature of the gas was increased to 450 Kelvin. So we could simply do that by reassigning the value of the temperature. So T is now 450. And really that should be it. So if the concentration has to be evaluated once more, we obtain the new value for the concentration based on the latest value for the temperature. Now that's it for variable assignments at this stage. As we build more complex code, we start writing scripts and so on, the importance of variables becomes much clearer. Then, aside the utilities we've seen now, let's talk about data types in MATLAB. Now, data types reflect the nature of the value held by a variable and the amount of memory it occupies. So this helps MATLAB when it comes to processing and storing the value in a correct manner. Now, among the common types, we have the character or the char, the string, logical, numeric. We've seen some of these up until now, complex, numbers, arrays, and matrices, and then structs. So let's discuss some of these one by one. Now, when it comes to characters and strings, now the char data type refers to variables that store characters or text, right, as the name implies. Now, the form is just variable name and then the character. However, you place the value within single quotes, and that is what tells MATLAB that, hey, what you have here is a character and or a sequence of characters. So whenever you have more than one placed within quotes, now each one is an individual character and they've been placed together. So that's an array of characters. Now the character data type is considered outdated and is being replaced by the string type in MATLAB. So really will not talk or use much of that from this point onwards. If we are going to deal with text, we would use the strings. Now a string is denoted using double quotes instead. So instead of the single quotes, use double. And MATLAB prefers to handle strings much more than it does for characters. So this is it for the alpha, the text data types. We've also seen logical. Logical refers to variables that store truth values, so true or false, basically. And it's used for comparison, to, decision making, conditions, and for filtering data. So you could have a data set, and there could be a rule that if the values fall within this category or pass this condition, those values are assigned true, and others are any other thing that does not meet that condition is assigned a false. And that's the easiest way to sort out data and filter out desired values from large data sets. It's also used for conditions. When we get to conditional statements, we realize that logical statements are an important part of uh, certain conditions when writing code for decision making and so on. So they're just true or false. Now, if you recall, the MATLAB value for these is 1 and 0, and this is passed when the condition is true. The other if the condition is not met. Now we have struct. So the structure is a bit more complex. It's used for storing related data or parameters together under a single variable. So usually its advantage shows when you are dealing with complicated code or more complex code. So assuming you are modeling some water piping network, you have a lot of pipes and with several inlets and outlets, and the junctions as well, where you have bends or joints within the piping at points where you are splitting some of the water or you are merging different streams. Now, at one point, because you are tracking water, you may want to track the properties of the water. So, at first inlet, you may be dealing with the temperature of the water, the pressure, the velocity, the composition, and so on. Now, if you have to create variables for all of these values, remember that you may not necessarily have one inlet and one outlet. There may be so many of them. And because you're also making computations for junctions, you end up having to define so many temperatures and pressures. At the end of the day, even variables which were meant to create some kind of convenience and add some kind of structure to your code, eventually you have so many variables and you lose some of those advantages. So what happens is it will be great if all the properties for water at the inlet could be placed under one variable. And that is what structures do, or struct does. So you are able to create um, a variable. So generally what you have is inlet 1. Right? And at inlet 1 you have the temperature, the pressure, the velocity, and the purity. So once you create this, it tells MATLAB that you have a structure or struct called inlet 1, under which you have the temperature, pressure, velocity, and the purity grouped. So all of these then fall under inlet 1. And then you can do same for inlet 2 and so on. Now, along the line, if you want to call any of these, you just call the variable name or the struct or the variable within the structure. So that's also a very convenient feature to have. Now let's talk more about uh, our major data type of interest, which is the numeric data types. Now you have for numeric data type, you have floats and integers. So int, as the name implies, it stores integer values but not decimals. So for whole numbers, in that sense. So for examples, -5, 0, 6, so on. Now the int data type can be grouped into signed and unsigned integers. So signed integers store the sign of the value as well as the value itself. Unsigned integers do not care about the sign. So as a result, they're only able to store positive values. Or they only store the magnitude of your value. They do not include the sign. And the representation for a signed integer is int. For an unsigned integer, a u comes before the int to indicate its unsigned properties. Now, integers are useful for integer programming, cases where your values can only take whole numbers. So maybe you are dealing with the number of people uh, or the number of whole entities, and you cannot have decimals in there. So in that case, you might want to just declare your variables as integers early on. So you do not have to deal with the inconvenience of ever having floats anywhere during computations. Now, there are also other cases. Generally, floats require more um, storage or memory for storing the float values because they use more digits. So there may be cases where you don't need those digits, as you said, for instance, in integer programming, you wouldn't want to bother with that level of accuracy because it's not necessary or precision. So what happens then is because you need memory or you may be computing, make large calculations and you have limited memory and you want to save some of that memory. So you might just want to go with integers so that you don't have to deal with the numbers after the decimal points that a float will include. Now to create an integer variable name as usual, and then you have to declare the variable type. So for it, because integers are not the default, even if you create a variable and you assign an integer value, MATLAB records it as a float. So it creates the space for the float with the zeros after the decimal point. So in order to enforce the integer uh, type on the value, you need to specify it. So the int is just the, so if it's uint, if it's an unsigned integer, then you use uint. If it's signed is int. Then you specify the bits. So in this case, for instance, you could have age equals int 8, 24. So we are essentially just saying that the age is 24, right? Age equals 24. However, you want to enforce that 24 is an integer. So it's not just that it's an 8-bit integer. So it's stored using 8 bits. Now for signed integers, the first part is the sign. So the first bit is used to store the sign. And as a result, you have 7 bits left for storing the value. So it could take usually up to 7 numerical places for this. Or you may want to store the height, and in that case, using 32. So this just shows that in 32 can store more larger values than int 8. Now, if we look at the types, you have int 8 stores about the storage size is 8 bits, stores for -128 to 127. Now it's a signed integer, so the sign matters. Now int 16 stores a relatively larger value from -32768 to the positive value. 32 were a very large number, and 64 even larger. So the way to determine the size or the range for an integer type is just int main and int max. So that will give you the range. I will look at this soon. And then the other type we have is the float. So let's take some examples for the integers. So we clear this. I'm able to just keep it. So let's say x equals, or let's say someone's age. So really, if an age cannot be a negative value, so if you were being efficient, you would not bother using the assigned integer because an age is always going to be a positive value. So if we just use uint and now age, usually an 8-bit should be enough, but we could go 16. You might be dealing with a very old person over here, so um, so now this creates an unsigned integer 32. So if we come here, we look at the class, it's an unsigned integer, 16-bit unsigned integer. Okay. Let's see what happens if we attempted to make it negative. So it's returns 0. It's not able to take the negative value. Now it's returning 0 because that is the lower limit for uint. So it tries to go down, but it stops at 0. So that's what you're going to get if you attempt to use a negative value. Now, if you needed it to be able to take negative values, then you have to make this a signed integer. Now, once you do that, it's actually able to take the negative sign. So that's in 16. And that is what my age is updated to. So at this point, let's clear our workspace. Let's clear the variables. And now, before we try any integer operations, let's explore the limits. So int min. Now you place this in single quotes. So if we want to check the limits for, say, a 32-bit integer, and that gives us the lower limit. If we wanted the upper limit, we could use int max instead. We could do for uint. That gives us the upper limit. We could check that the lower limit is 0. Which is why when we try to assign a negative value, we obtain 0 the last time. So these functions allow you to check the limits of every integer. So we could use 64. That should still be 0. But if we check int max, it should be a much larger value. Now for integer operation, so let's see x equals int 16. So that is 24. And then y should also be int 16. Let's say that is 350. I'm going to suppress it. So let's see what happens when we have so that's just addition, but it reports it in the format that the variables were created. So this is the sum of two integers of the same type. We could also perform the normal let's say u equals z minus y. Now let's try division and see what happens. So if we divide, say, let's say x is 24, so let's try to divide it by 4. Now let's call that q equals x 24 and see what happens. So that performs integer division and we obtain 6. Right, so if we come here, we check the class, q is a 16-bit integer. Now let's try some division that does not lead to a round number. So let's say r was x, which is 24. R was x on 5. Now we obtain 5. So MATLAB just runs to the nearest whole number. We could have done x 4.5. Let's see what that returns. It still gives us 5. So it rounds up to the nearest whole number. Now, different programs handle integer division differently. I believe for some programming languages, what happens is a truncation instead of rounding up. So if we check here where we declared r to be x on 5, 24 divided by 5 should return a decimal. Right? If you were working with decimals, that should return a decimal. So it should really be 4 with a remainder, like very close to 5. Now, other programming languages will just truncate the decimal part. So you would have 4. I believe Python works like that. You'd have 4. regardless. But for MATLAB, that leads to a rounding up to the nearest integer. So we could try other things, unsigned versus signed. If you computed something between an unsigned integer and signed integer, or integer of different types, you could try that out and see what happens. If you perform division between int 16 and int 32, those are some examples you can try to explore more about integers. But let's move to floating point. So a float is a number. So that's a floating point number, and it's a data type used to store decimal values or the continuous range of numbers. So 1.03.14 and so on are all decimals. Now floats are high precision approximations of real values. Decimals are high precision approximations. So usually in engineering, you need to perform calculation with floats or decimal points. It could be because of the quantities you're handling. Now, depending on the units, those decimal points might be very crucial to the accuracy of your calculations. Sometimes, especially during solutions involving numerical methods, for instance, what happens is you have errors associated with the computation, usually trying to balance different sides of an equation, and you want those computations to be in floats as precise as possible to reduce the diffusion of errors throughout your program. So some quantities also just take floats, and they are usually very commonly important and used in everyday science and math. Now, in MATLAB, there are two types. There's single precision and double precision. Single precision stores fewer digits than double precision, so it's less precise. Now, the default type in MATLAB is the double precision floating decimal. So x equals 15 stores 15 points, 0, 0, 0, and those zeros are placeholders for all the values the double precision float holds. Now, for single precision, you would need to declare that you are defining your value as a single precision value instead of double precision. So if you just place 15 there, the default will be assigned, which is a double precision float. So everything we've been doing up until now, and most of what we'll be doing subsequently, will be working with floats, specifically double precision floats. Now, there are also complex numbers or complex data types. So MATLAB also stores complex numbers written in this form, and there are functions that can be used. So we have real apps and so on, and that is used for operations involving complex numbers. So if we come here and let's say 4 plus 5i. Now this MATLAB is able to interpret this as a complex number, and when you come here to the class, you're able to see that it's a double complex. You can perform a number of functions. So, but to make this easier, let's create a variable. So let's clear paths. And then let's assign this to x. This is laziness. So x is 4 plus 5i. Now I can have real x. So that should give me the real part of this. I can also have the imaginary part. Five and so on. I can compute different things from this complex number. Now let's talk about arrays, arguably one of the most important data types in MATLAB. Now an array is an ordered collection of data or elements. So now a scalar is a one-by-one array. So vectors, matrices, scalars, tensors, all of these are potentially arrays. So just as you have a set, which is a collection of elements, or unique elements. You have arrays, when the main difference being arrays order the data. So the data usually is ordered, and arrays allow duplicates while sets do not. Now, most of the time, you would have to work with arrays. You have a collection of data, related data. So you could have a range of temperatures. Assuming an experiment was carried out and you vary temperature, you have a range of temperatures and a corresponding output variable that that temperature determines. So maybe the temperature, you're using the temperature to determine the composition of at the outlet of a unit, or you are using the temperature to determine the pressure. So you vary temperature and see what effect that has on the output of that system. And when you collect all of that down, you'd have an array of values or elements. So you have different temperatures and their corresponding outlets, or different measurements and their corresponding values. Now, depending on the nature of your experiment, you'd have a vector or a matrix, depending on the dimensions of your work or your study. So this sounds a bit complex right now, and usually as you go up ahead, it gets a bit more complex. But at the fundamental level, it's a simple thing to understand. And the reason we are mentioning now is very soon we will start using some of these, and it's actually the language of MATLAB. MATLAB works in arrays, vectors, matrices, everything. It's some kind of an array. So you can reduce arrays down to a single digit, in that case, which is a scalar. So a scalar is just a zero-dimensional array, or one by one. So if you start with a tensor, which is a 3D array or higher, you have n by n by n. Matrix or matrices are 2D arrays indexed by rows and columns. A vector is just a one-dimensional array of elements, and then a scalar is a zero-dimensional array. So it's just one value. So technically, all vectors are matrices, and which are all tensors and so on. MATLAB works using arrays, and even a single numerical value is a one by one array. So because that's the language of MATLAB, we are going to mention that earlier on. We'll start seeing some of those as we proceed. And it's crucial to know the type of array a variable holds in order to perform the right operations. Some operations are array operations. Some of them, if you're dealing with a matrix, you need to be sure of the particular type, data type that variable holds. So sometimes you may be dividing two things, or you may be trying to combine two variables, and because they hold different data types or different arrays, one may be a vector, you may be trying to merge a row vector and a column vector in a way that is incompatible, and you would have issues with your code at that point. If you don't get an error, you have the computation proceed, but you would have wrong results because you've not MATLAB is interpreting your operation in a very different manner. So it's important we start keeping track of arrays early on as we build up our fundamentals. So that brings us to the end of our first lesson on MATLAB for Engineers, brought to you by the GAD Academy. In our next lesson, we will touch on vectors and matrices, and look at arrays in general proper. I'll see you there.